this lesson, we're going to work on dividing decimals. Of course, our objectives are to figure out what the exact result is when you need to divide decimals out. Working backwards with the area formula, you can determine the width of a rectangle when you know its decimal area. And also, you can convert back and forth between centimeters and inches. Several things you need to know before you begin. You're going to have to know your single-digit multiplication facts, and we're not going over the division algorithm in this, so we expect you to already know how to do long division. So, find the quotient. The key characteristic behind this thing, of course, is that we know you'd be able to set up division with noting 31 and 408 thousandths divided by 5 2/10. The difficulty we encounter when you're dividing decimals is that having a decimal on the outside is a problem. It's kind of hard to sit there and say, oh, well, what are your multiples of 5.2? Having decimals on the outside, because we would look at this and say, how many times does 5.2 fit inside 31? That's not a question that most people can easily answer, and so to try to make it a little bit simpler, we've got this rule that if you have a decimal on the outside, we're just going to move it. If we move it one spot to the right, we will have to move the decimal on the inside the same amount, one spot to the right. And so moving that decimal actually notes then that we would have 52 on the outside, 314.08 on our interior, and now we can just do this division, stacking our decimals on top. Running through the division algorithm, how many times does 52 fit inside 314? Now you may remember one of the tricks that sometimes people will use is to say, ignore the last number of each one. How many times will 5 fit inside 31? 6. That'll get you ballpark close. It's not a guarantee to always be correct, but it gets you close. It gives you a good guess. So we would say 6 times as our guess, and 52 multiplied by 6 actually gives you 312. We know that we'd subtract, drop the next one. How many times will 52 fit inside 20? 0. So we'll put down our 0, drop the next number. How many times will it fit inside 208? So once again, you can cross off the last number. How many times does 5 go into 20? 4. So that's going to be our guess. 52 multiplied by 4. 2 times 8. 2 times 4 times 5. We actually wind up getting a perfect result, no remainder. And so we're done. Our answer is 6 4/100. This process, where we need to move decimals, is going to be the primary characteristic that we pay attention to. For this one, we have 104.32 divided by 4. You'll notice we have absolutely no decimal on the outside, so we don't have to worry about moving them. With no decimal on the outside, we'll just start by stacking our decimals here and say, let's get started. 4 will fit inside 10 twice, leading to a remainder of 2. 4 will fit inside 24 6 times, leading to no remainder. 4 going into 3? 0. Not at all, 0 times, so we'll drop our next one. 4 going into 32. That's 8 of them. And so we're done. We wind up with our answer, 26 8/100 for our quotient. What about here? 18 15.6 divided by 0.02. This one does have a decimal on the outside, which of course is our problem, so we'll have to move the decimal 2 places on the outside
And add the zeros.
and 2 places for the inside. That sets us up 2 and 1860. Stacking the decimals again. Running through our division, 2 goes into 18 9 times without a remainder. 2 goes into 6 3 times without a remainder. And one of the more common issues that sometimes students will do is they get to this point where like, okay, there's nothing left, and so they just leave the answer as 93. That's not accurate. The reason I made sure to put this decimal up here is so that you would know, at the very least, you have to keep dividing until the decimal.
The 900.
2 will go into 0, not at all. It's actually 930, not 93. Making certain that you don't stop dividing before you're allowed is, of course, a critical component to this. Okay. What about in the context of some geometry? Well, we know that length times width equals area for a rectangle. And so area divided by the width will give us that length, or the height, however you want it. If you want to call it base and height, length and width, that's up to you for how you want to label it.
Yeah.
Key characteristic that we're looking at, though, we are taking this area and dividing by the side length we know. This is being set up 144.06 divided by 14.7, and we have to conduct this long division. So I'm going to change colors so that it'll show up a little bit better on this darker side. We know that we have to move the decimal 1 position to get rid of that decimal on the outside, and thus our problem is here. So how many times will 147 fit inside 144?
10.
It won't. 147 going into 1440, we can go off and get some scratch work. 147 multiplied by 9. Okay, 9 times 7 is 63. 9 times 4 is 36. Plus 6 gives us 42. 9 times 1 plus 4 is 13. And so we've got 9 of them going in 1323. Okay, working through our subtraction, we'll have to borrow. 10 subtract 3, 3 subtract 1, 1, 4 subtract 3, and now we'll drop our 6. How many times will 147 go inside 1186? Okay, taking a guess of 8, 147 times 8. 7 times 8 is 56.
40.
8 times 4 is 32. 32 plus 5 gives us 37. And then 11, so we wind up with 8 and 1176. Okay, bringing that down, we wind up with 10. And now what? And you know that we'd have to add and drop another 0. But 147 does not fit inside 100. So we'd have to add and drop another 0.
So you balance them.
And it's worth noting, at a certain point, these pieces can wind up being very, very long. We could wind up with a really, really long decimal, which is why when you're working with your homework, it wasn't, whoa, that's messed up.
See that?
It wasn't posted here, but our directions within your homework do say, round your answer to the nearest 100. So round your answer to the nearest 2 decimal places, And right now we have the 8, 0. And so what we'll wind up with the next digit is going to tell us if we're going to round down to 8, 0 or if we should round up to 0.81. How many times will 147 fit inside 1,000? My guess on that is going to be 6. And I'm thinking 6 because 147, if we were to take that off from the 1176, that's still going to be over 1,000.
Yeah.
So taking 6 of them, we've got 42. 6 times 4 is 24. Plus 4 gives us 28. And so 6 of them leads to 882. And I don't even really care what the remainder is going to be because 9.806 will still allow me to round my answer to 2 decimal places.
It would be, whoa, it would be 118.
That's 9.81. Rounded to the nearest foot. And there we're finished. For the last problem in our lesson, we know that there are 2.54 centimeters in 1 inch. Conversion that's worth memorizing. So how many inches are there in 108.17 centimeters? Again, round our answers to the nearest 10. So we'll round it to the nearest 1 decimal place. Well, this is a conversion that requires us to take our centimeters, divide it by 2.54, and that's going to give us our answer in inches. Thus, we need to set up our long division and say 108.17 divided by 2.54. We'll move our decimal place 2 points. And so we're working through 254 divided into 10,817. So let's continue with it. 254 is going to fit inside 10,081 how many times?
9.
Well, if you're not sure about it, remember, you can cross off the last number. How many times does 25 go inside 108? That would be 4 times. So 4 is a good guess on what we should try out here. 254 multiplied by 4 gives us 1,016. So 4, 1,016, leading us to a remainder of 65. Dropping our next digit, how many times will 254 fit inside 657? Looking at that and saying 2. Because 250 times 3 is 750. That's obviously too big. So 8, 10, 5. 2 of them leads to 508. Here we'll borrow. Get 9 for 149 as our remainder. And drop the next 0. 254 going inside 149. 8, and he's saying 5, so 254 multiplied by 5. So it's 20, 7, and 12. So 1270 for 5 of them. So 0, 2, with a remainder of 220. And we're still going to have to do one more, so we'll be able to round it to the nearest 10. How many times will 254 fit inside 2,220? This is the point that I'm just going to note. I don't know, but definitely more than 5.
6.
No, seriously, we know that if it's over 5, we're going to wind up rounding up. 5 is 1270. It's definitely going to go in more than 5. Maybe it's 8, maybe it's 9, but it doesn't matter if it's 8 or 9 or 7. 7, 8, 9 all tell you to round up, so who cares if it's 7 or 8 or 9? Ultimately, we know whatever this last number is going to tell us to round up. So if we're looking at saving ourselves a little bit of time and a little bit of effort, it's going to round up anyway, so we'll just say 42.6 and round it, and there we're done. We'd be able to convert between centimeters and inches by setting up our decimal division. We are able to determine side lengths of rectangles by setting up decimal division and paying attention to if we have to move a decimal or not move a decimal. Either way, we can set up our division and get our answers.